Welcome everybody. So this is the introduction to the Top Master Nano Science program. I'm Thomas Jansen. I'm the Deputy Director of the program, so I'm the person responsible for the program. And I'm going to inform you about what is this program all about. So the aim of our program is to train the next generation nanoscientists. And the field of nanoscience is a very challenging field. It's very rapidly changing, and it's interdisciplinary, so it involves elements from physics, chemistry, and biology, which means that we have to do this in a very special way in order to make sure to be successful. So what we do is we build up the program around the so-called research cycle. So there's during research there's number of elements coming together. So you might naturally start with design of systems, then you make synthesis and device building, you do characterization, and then from that you go further to the theoretical foundation in order to understand what you have really made, and then you might go proceed back and make some kind of improved design of your system. This 2-year program. So this is a highlight of the first year. So since it's an interdisciplinary program, we have students with physics and chemistry background, and sometimes also students with some bio-oriented background. So that means that in the beginning you have to get up to speed with what everybody else can. So that means that for the physics students, for the students with the physics background, they will have a guided self-study in chemistry, which is focusing on organic and inorganic chemistry. For students with a chemistry background, there will be a initial training in quantum physics and in solid-state physics. So this is about a month, and after that month, the core modules start. So that is modules that are training in the preparation, characterization, and the fundamental properties of nanomaterials. And essentially, these core courses contain a lot of smaller units. And you can see all the details on our website, but this is the key things. It's a very intensive period. There's 15 exams, I think, in that half a year. So there's a lot of things to catch up with, and it's very challenging. After this, the basic training of the basic theoretical, mostly training, is finished, and the rest of the master is centered around 4 individual projects. So the first of these individual projects is a research paper. So there you have to write a kind of review paper of approximately 15 pages length, and there are workshops training you in doing literature research, training in writing, and also teaching you ethical aspects of science. And this is taking a bit more than a month. It's a little bit a fluent transition period to the next project, which is the small research project. So while finishing the last pieces of the paper, you will also start the small research project, where you will go into the labs of one of our research groups, and it's essentially something like another bachelor project approximately in size. There will also be workshops on presentation skills. One of the important things here is that you don't have to write a thesis or on the research here, or a report. You are graded on a presentation that you will give at a symposium, and you are graded on the logbook that you have to keep. So you have to keep a research logbook, and you are trained in that. Actually, that's not standing here, but there are workshops telling you how to keep this logbook, and there are workshops on presentation skills, so you're prepared for the presentation. And the presentations of the students are all given in one day in a symposium, where that symposium is organized by the students themselves. So that means that you have to take care of everything from catering to sponsors to an external speaker, and of course you have to give your own presentation. And you have to make sure that there's an audience, so that's also very important. So you have to make sure that people know that it's there. You can see there's 4 here, so that's the beginning of the electives. So there will be a number of electives that you can spread over these periods. And of course that depends on exactly which electives you're choosing. The second year is focused on the big master project, and that's in that sense not so much different from most other master programs. One thing that is really different is that we are also having a PhD research proposal, and that is with the idea that if we want to train you to proceed in academia, then one thing that you really have to know about, and one of the things that is needed in order to be successful, is to write grant proposals in order to get money for doing research. So we have this research proposal where you essentially are trained in writing a proposal that is kind of intended to be describing a PhD research project. So that's the structure of the program. And as I already said, it's very challenging program. It's very intensive. Still, more than 80% of the nanoscience students actually normally graduate on time. And you can ask yourself, why is that? So of course, one of the reasons is that the program is selective. Yeah, so we select a small group of students, not more than 15. And of course, that means that we can also give these 15 students a lot of attention. And when you got a lot of attention, it's easier to make sure that you graduate on time. Yeah, so we take care of giving a lot of coaching. The small group size means that it's essentially working as a learning community. We really motivate the students to study together, help each other, be really a group. We furthermore provide scholarships. These are provided in general to all students, but they are tailored to the needs of the students. So people that need more support, we can also support more, while people who have financial means to support themselves will have less scholarship. The program is also very much hands-on. There's a lot of practica. There are a lot of things where you will be in a lab, and of course during the individual projects you will really be doing research in the labs. So I think one of the, the highlight of the first year of the program is the Nano Symposium. So I think this is really a special event, and you can visit this website. There you can see from last year's cohort how they designed the symposium, and this symposium this year is also going to be held somewhere end of June. You're very much welcome to attend and see how it's going. It's very nice in the sense that you get really an impression of all the research that is going on within the topic of nanoscience at the university. You're also encouraged to visit our website, so the very long URL is standing down there. There's a lot of information about the program. You can find essentially all the information that you can imagine. Of course, you can also use this day to ask questions. So the vision of the program is really to use our outstanding research institute here in Groningen to train the students, and we are trying to recruit the best students and preparing them for this very dynamic research field of nanoscience. So you will get the training of top researchers in the field. We are not the only ones saying that this is a good program. So it's very nice to see. Yeah, so the program started in 2003, and it has been evaluated by the so-called CANU, which is an institution evaluating all educational programs. And in all these years here, we have been evaluated as excellent, which is the highest standard that you can have, and by the Keuzegids Hoger Onderwijs. We have been evaluated since 2012 as one of the top 3 programs every year, and in 2019 we were evaluated as the best program once again. I think this is of course very nice to see also that other people also think that we are a good program. This does not necessarily mean that it's a program for you. So the question is, of course, is this something that you want to engage in? If you think that things like new ideas, research, hands-on activities, designing new materials, new molecules, and a very international and interdisciplinary environment, if you think that's cool, so we have a very large fraction of international students. If you think this is cool, if you think that it could be cool to do a PhD afterwards, then this might be the program for you. These are kind of some of the topics that you might think this is cool. And if you like to address some of these questions maybe, or other questions that are essentially, we try to train you in doing fundamental research on open research questions. So how can we make better superconductors? We have things that are related to virus research, quantum information. How can you make better solar cells, better batteries? These are, I think, all topics that are very much important for our society at the moment. The groups that you can do research in are listed on this list here. So these 4 research projects, of the 4 research projects, 3 of them have to be done in different groups. And we really encourage you to go out of your comfort zone as a student in the program. And if you do a program or a project in chemistry, do a project in physics as well. Or if you do projects that are experimental, then do something theoretical as well. Try to make a combination that also makes sure that you challenge yourself and you learn to speak the languages of different research directions, because that is really key, that you can make connections between different disciplines in order to be successful. So the research that have been done by our students have led to different projects, including some of the papers that I'm just going to flash through here. So things on nanowires fabricated here. There's something with 2-dimensional superconductivity. People have been working on magnon spin information. So this is on spin lifetime. And we have a project here which was on biophotovoltaics, so using bio molecules in photovoltaic devices. And this thing here is a like a memory, or it's a memoristor, which is a kind of device that mimic the way that the brain is working. So the idea is to make a kind of chip that works in ways inspired by how the brain works. So our students have been quite successful during the time. So here are 2 examples of Elizabeth Dynastay got the Avril McDonald Award last year, and Anouk Rossens got a Shell, how do you call it, afstudeerprijs, so that's a finishing your study prize. So, master's thesis prize. This is the overview of our current students. Maybe you know some of the faces, so you are very welcome to approach them and ask questions. They are typically very willing to tell about the program. And Tøyen, who's down here, he's also in the back of the room and will be willing to ask questions. How to apply. I'm now writing here the prescription for so-called Dutch students. So with that, I just mean students that are graduating at a university in the Netherlands. If you belong to this group, you should contact Karin de Jonge to let her know that you will be applying. Here are the information about what kind of things that you have to provide. Yes, so CV, motivation letter, transcript. For students from Dutch universities, you don't have to prove your English proficiency. You have to provide recommendation letters and a copy of passport or Dutch ID. These are our deadlines, and depending on before which deadline you hand in the documents, we will look at the applicants and we will invite the best for interview, and that will then be either in February, May, or in June. And you don't have to wait till this EU deadline with applying. If you apply before the 1st of February, we will look at your application at that time. And with that, I reached the point of questions. Maybe I should say here that if you want more information about the application process, especially, you should contact Karin de Jonge on this email address. If you want information general about the study, then you can ask Geertje Sondervan, who is not at stand 2 at the moment, but sitting here in front of the audience. And other information, you are also always welcome to approach me, and you are indeed also very welcome to approach our former students. And Tøyen is also here to answer questions you might have. You can also follow us on Twitter and on Facebook. So I hope that was clear to you. Otherwise, I'm very happy to answer any question you may have. Yeah.
What kind of electives do students take?
So we have a very broad choice of electives. So essentially, you can choose from a very broad range of physics, chemistry, and biophysics or biochemistry related electives. So the choice is very broad. So it's essentially broader than if you would just follow our physics program or our chemistry program. You can take some electives from chemistry and some from physics. So I don't know if there's specific electives or types of electives that you are interested in, but there's really a broad range. And we also often have students coming to us and say, well, I would really like to take this elective. And if we decide that that particular elective is actually relevant for the study of the student, then we will evaluate if we will simply add it to our list of electives if it's not already there. So there's a very big chunk of electives that you can choose from. And maybe I should also say that in the beginning of the program, you are assigned a mentor, which is a professor at the institute, and that professor will also help you make the choices, because you have to choose electives, you have to choose these different individual projects, and they can help you with advice, especially if you when you want to go out of your comfort zone and try something that is you might not really be familiar with the professors that are doing that particular kind of research. Other questions? Okay. Yeah, there's a question.
How many applicants are there per year?
So we have typically something like 60 to 70 applicants from all over the world. And typically we invite half of them for interview here in Groningen. And yeah, we would like to ideally have about 15 students. If you count here, we don't have 15 students every year, so there's definitely room for enthusiastic and talented students in the program. Yeah. Other questions? Yeah.
You said you do multiple applications so that you can ask if you can join or not, and that you will hear it a couple of weeks after. But if you have 15 people in one group at the end, how do you know how many people you can have in a certain time? Or is the last selection at the end?
So this could be a problem indeed, as you indicate. As long as we are not on the 15, we don't face that problem. So we haven't really had that problem in recent years, but we have had the situation where we say people that are kind of on borderline, if we think that we will invite them and they are in the they applied for this deadline here, then we say, well, you are on a waiting list, and we will inform you a bit later. So the final decisions are only taken really in June, but if we are fully convinced about that student will be fit, or the students will be fitting within the program, then we will let them know as soon as we know. So students that are admitted or that are applying in November, most of them will know in the beginning of March actually if they will be admitted, and if we're in doubt, then they might be on a standby list. Okay, if there's no more questions, thanks a lot.